Hi, Dr. Dyer here, talking about research in human development and family science. So, what is science anyway? What is this tool that we are using to learn about how humans develop and close personal relationships? Carl Sagan very famously said that science is more than a body of knowledge. It's more than a collection of facts. It's more than information. It is a way of thinking. It is the process by which that information is learned in the first place. He says it's a way of skeptically interrogating the universe. So let's continue thinking about science as a process, as a way of learning. I would say that science can be defined by these characteristics. The actual step-by-step procedures differ quite drastically from one research project to another, but these are things that, to be science, it has all these things in common. The first, let's start there, is systematic empiricism. Now, empiricism originally is a concept that came from ancient Greece. Aristotle was an empiricist. He said that knowledge is more sound, more true, more dependable, more real if it comes from one's own senses rather than from rational thought alone. I think of this as the difference between going out into the world to look at it, to measure it, to touch it, to observe it. That's empiricism, as opposed to sitting in a room and thinking about what the world must be like. When you think of it that way, obviously empiricism is a better way of knowing about the world. And science kind of says, yeah, that's going to be our shtick. That's what we're going to do, is we're going to produce knowledge that is based on direct observation of the world. Empiricism didn't really take off, though, until the scientific revolution in Europe. This is the first drawing, the first image the world ever saw of what a fetus in utero actually looked like. Da Vinci was able to produce this drawing by dissecting the body of a pregnant woman. And this is empiricism. We had to actually look to know what was going on inside a pregnant uterus. Galileo, of course, turned his telescopes on the planets and began to directly observe them rather than to simply speculate and use his rational thought processes to figure out what the ellipses of the planets were like. He turned the telescope on the planets to directly look at them. So this is empiricism, and during the scientific revolution it really took off. But scientific empiricism looks a little different than just philosophical empiricism. Scientific empiricism is systematic. And the reason is something that we have talked about at length already in Chapter 2. Human perception and cognition is biased. We can't necessarily always trust our own observations of the world because our brains have certain biases, right? So we can't purely rely on direct observations. Therefore, scientific empiricism must take specific precautions to overcome those biases. Specifically, observations have to be systematic in some particular ways that let's talk about. Systematic empiricism shapes the way that science approaches sampling and measurement in order to correct for the biases of the human mind, but to still use the principle that knowledge is more reliable when it comes from direct observation. Let me use an example to illustrate what I mean by systematic empiricism, and let me use an example relevant to HDFS. You may have seen this product, Your Baby Can Read, and you might say to yourself, your baby can read? If you're studying human development, you're probably pretty sure that a baby can't read, right? This is, in fact, a pseudoscientific product, and infants, babies really can't read. But let's say that we want to test this assertion. We want to use science to respond to this assertion that your baby can read. We would have to do science on babies reading. For one thing, we would have to have more than just one baby. We would need a sample of babies, and we would have to measure whether or not they can actually read. The first thing we'd have to do is to be very focused on the issue of reading. We would decide in advance that we wanted to study reading in a group of infants, and we would decide, we'd be very focused before we started that that's what we're doing. We're not going to be able to reflect back on babies we've known in our life and whether they could read or not. That's not systematic enough. We're going to think of it first and then move forward in time, specifically focused on measuring whether babies can read. The second thing we'd have to do is very explicitly and clearly come up with a definition of reading. How will we know when we see a baby reading? These videos, Your Baby Can Read videos, show an example of the word clap on the screen, C-L-A-P, and they show a baby clapping, and that is their evidence that the baby can clap. That might be reasonable evidence. That baby can read. That might be reasonable evidence to say that there's a word, and if the baby understands that, they will act it out. That might be a reasonable way of judging that the baby can read, but we need to decide that in advance, that that's how we're going to define reading. The third thing we have to do is apply that test to all the babies in the study, and we have to be really careful about how we get that sample of babies. They need to be representative of babies in general. They can't just be the children of this person here who has produced this pseudoscientific product. They have to be selected in a way that we can say is relatively unbiased. And then we have to measure reading in exactly the same way on all of those babies. Finally, we would want to document whether those babies could read. So we'd probably want to film every single baby in our sample through whatever measure we're going to use to study whether they can read, and document each one so that our memories do not fail us, and confirmation bias doesn't kick in. We have it all kind of documented and recorded. So that's what I mean by systematic empiricism. We will talk more about it as we continue to talk about sampling and measurement.